Hi, I'm Benny D, and in this video we're going to be looking at differentiating rational powers. Okay, these are reasonably straightforward because the rule still holds as it would for f of x equals x to the power n, okay, where we bring n down the front and take 1 away from n. Okay, the same thing works for our rational powers. So what we say is if f of x equals x to the power of p on q, so some fraction, then f dash of x equals p on q, x to the power of p on q minus 1. So the same thing is happening as what we usually have here, where we bring n down the front and then we take 1 away from n in the power. The same thing's happening. Okay, we bring this power that we had down the front and take 1 away from it. Okay, so we'll look at a few worked examples here. So the first one that we've got is differentiate f of x equals x to the power of a half. Okay, well, we're going to bring the half down the front, take 1 away. We've got half take 1 gives us negative a half. Okay, and then what you want to do is express this with a positive power, a positive index. So it's going to become 1 over 2 root x. Okay, because remember, a half is really, a power of a half, is the square root. Okay, and with our half out the front here, we're going to get this coefficient of 2 down the bottom. Okay. When we have a look at this next one, f of x equals x to the power of a third. Okay, we see that, and this should be f dash of x, of course. Right, f dash of x, okay, it's going to be 1/3 down the front. Okay, minus 1. Now, common misconception or common little error to say the power is now negative a third. Makes sense because we had a half up here, we've made it negative a half, but it's not so. Okay, 1/3 minus 1 is negative 2/3. So you just need to be a little bit careful there. Expressing this with a positive index means that we get 1 over 3 times the cube root of x squared. So remember from our index laws, a third means that we've got the cube root, and with the 2 on the top, that means that we can say it's x squared. Okay, so it's the cube root of x squared. Okay, we'll have a look at this one now. We've got f of x equals x to the power of 4 on 5, so f dash of x. Okay, same thing's going to happen. We're going to have 4 on 5. Okay, come down the front, and then going to be x to the power of negative 1/5. Okay, because 4/5 minus 1 is negative 1/5. Express it with a positive index. We have 4 on 5 times the 5th root of x. Okay. Our other example here, we've got f of x equals 5x to the power of 2 on 7. Okay, so this time we've got to bring a power down the front and times it by 5. So that's going to give us 10 on 7. X to the power of negative 5 on 7. Okay, expressing that as a positive power, we're going to get 10 over 7 times the 7th root of x to the 5. Okay. Or you could write it, when we're getting a bit more complicated with our fractions, okay, we could just put it in the denominator here as x to the power of positive 5 on 7. Okay, we don't always have to turn it into like the 7th root of x to the 5. Okay, so we could just leave it as 10 on 7x to the 5 on 7. Okay, that would be acceptable as well. Right, now, using this, okay, can still apply to our chain rule. Okay, so I've got f of x equals the cube root of 2x cubed plus 4. Okay, so this is a chain rule because we've got a function, 2x cubed plus 4 inside a function, which is the cube root of x here. Okay, so I'm going to show you the way that I like to do these questions. It is slightly different to the what you'll see on the formula sheet. Okay, I like to say, okay, what have we got? Well, actually, I'm going to change this slightly, okay, just so I can use the normal way that I write this rule. So we've got h of x equals that, okay, and we're going to say then if h of x equals f of g of x, okay, then h dash of x equals g dash of x, f dash of g of x. Okay, so it's a way that we can actually write the chain rule down. If you are used to seeing the chain rule as dy dx equals dy du times du dx. Okay, that's great, but I personally just don't like that quite as much because, look, you'll see it on formula sheet like this all the time, but it just sort of tells you this. It doesn't actually give you an indication of how to do it so much, and so you always need like an example showing how to do it. This way is a little bit different, and I think works a little bit better, and the way I set it out is exactly the way I set out all my differentiation questions, whether it's chain rule, product rule, or quotient rule. Okay, so here's how it goes. I write down f of x. Okay, so this is my main function here, which is the cube root of x, or x to the power of 1/3. I write down g of x. Okay, that's what's been subbed in. So that's our 2x cubed plus 4. Okay, then I go f dash of x. Okay, I'll find the derivative. So it's 1/3 x to the power negative 2/3. Okay, and I'll find the derivative of g of x. So g dash of x equals 6x squared. Okay, and this is how I would start this. Okay, no matter whether it's chain rule, product rule, or quotient rule. Okay, now all I've got to do to find h dash of x is just build up my answer. Okay, so I know it's g dash of x, so that's 6x squared. Okay, times by f dash. Okay, so I times it by 1 on 3. Okay, and now wherever I go on x, okay, I'm going to put g of x. So that's 2x cubed plus 4, 8 to the power of negative 2/3. My 6 and my 3 are going to cancel out, leaving me with a 2 in the numerator. So I'm going to say I've got 2x squared over the cube root of 2x cubed plus 4 squared. Because my 2 in my numerator squares what's being put inside my cube root function. Okay, so this is the way I like it. Often you'll see it as said a little bit differently in the textbooks, and that's okay. I just strongly encourage you to be consistent with whichever method you use, okay, and use whichever ones make sense for you. So look, hopefully that'll get you through differentiation of rational powers.